Today we're talking about finding the slope from graphs. I'm going to quickly go through the starter just to make sure that we understand how to plot ordered pairs. Before we do that, we just have to reacquaint ourselves with the Cartesian coordinate system, which is the name for something that looks like so. Keep in mind, on the Cartesian coordinate system, we have two axes, the x-axis, which is horizontal, and the y-axis, which is vertical. The x-axis has positive numbers on the right and negative numbers on the left. Positive numbers up, and negative numbers down on the y-axis. Oops. It has four quadrants, quadrant 1 being the top right corner, quadrant 2 being the top left corner, quadrant 3 being bottom left, and quadrant 4 being bottom right. We rotate in a counterclockwise direction. And we always start at the origin, which is where the two lines cross, which will always be 0, 0. So a quick refresher of how to plot points before we begin today's lesson. You'll notice on your starter you have 6. On the starter you have 12. I'm only going to do 6. Keep in mind, when we plot points, we always go x, y, every single time. So we start at the x coordinate. So in this case, the x portion of our coordinate is 3. So I'm going to go to the x-axis and I'm going to move over 3 spaces. From there, we can go ahead and move in the y direction, which is in this case positive 4, so that means we're going to go up 4. I know that we're going up 4 because it is positive. So I'm going to go ahead and put a purple dot right there to say that's a combination of the blue and the red. We can repeat this process for the other 5 points. So let's first start with our blue. In this case, we're moving in a negative direction, so I'm going to go over -6, 2, 3, 4, 5, 6, and then up 3. We'll put our dot right there. Keep going. We're going to go over -4. 1, 2, 3, 4. In this case, we don't move up or down at all because we have a 0, so our dot is going to be on the axis itself. Let's keep going. We have -6, so that means we're going to go over 6. 1, 2, 3, 4, 5, 6. Keep in mind that we're moving in a negative direction because we have a negative number there. Similarly, we're going to move in a negative direction because we have a negative number here. 1, 2, 3. I'm going to put a dot right there. Now, once again, we have a positive number, so we'll move in a positive direction. 2, 3. Then we're going to move in a negative direction, up and down, for the y value for it. We have one more point to plot. We're going to go over 5, and then up 7. Plot the other 6 points on your own. Once you have done that, let's go ahead and move into the meat of today's lesson. We are talking about slope. Slope is the steepness of a line. It is also nicknamed the rate of change. But that isn't the answer to the blanks. Slope is defined as the rise over the run. In and is represented by the letter M. Why did they pick M? I don't know. It's just what they picked. Okay. Another way of to say this is how far left and right. You have to move over how far up and down you move. Let's try some examples. Now you'll notice my lines kind of look like the lines on your paper, but they're not the exact same because I'm not working off of your notes. So we'll start here at this first line. You'll notice that we have a line with 2 defined points on it, okay? We first need to figure out the rise. How much do you have to go up to go from one point to the other? How much do we rise? We go up 1, up 2, up 3. Now, if you think about this in terms of the numbers on the line, we're going from 1 to 4. That is going up in a positive direction. So let's go ahead and write positive 3. So our rise is positive 3. Our run is going to be moving in the other direction. We go up and over. We rise positive 1 because we only moved over 1 square. Keep in mind we want to keep to the grids. So then to write our slope, we want our rise. Oops, I wrote the wrong word, didn't I? We want rise over run for our slope, which will be positive 3 over 1. This is what we would call a positive slope. As you look at it from left to right, it's going up. Please familiarize yourself with this term, as the first question on your assessment is, what does a positive slope look like? Draw an example. So an example would be something like, oh, I drew a positive slope. There are lots of right answers. So our M was rise over run, which is 3 over 1. Let's go ahead and try it the other direction now. We have a line with 2 points once again. So let's just go from one to the other on the grid. Now there are 2 ways you could go. You could go this way, or you could go this way. Either way, you should end up with the same answer. However, let's keep it to rise over run. So in this case, how much do we rise? Well, we rise 1, 2, but notice, are we going up or are we going down? If you think about the numbers on the side, that's going to be going from 4 to 2 in a negative direction. So our rise in this case is going to be negative 2. We went down 2. Let's figure out our run. How much do we go in a positive direction? We went over 1, 2, 3. So our run is going to be positive 3. So our M value, our slope, is going to be rise over run, which will be negative 2 over 3. Fractions are okay, but make sure we reduce. Now looking at this line, as you look at it from left to right, it's going downwards. So we look at it from left to right, it's going down. We would call this a negative slope. As you look at it from left to right, it's going down. That is the second question to your assessment this time. Draw an example of a negative slope. So your answer would be something like, you draw a little coordinate system in, and you draw a line going down as you look at it from left to right. But once again, there are lots of correct answers. You'll notice you have one more example under notes. I'll give you a hint. It's a negative slope. See if you can figure out what the slope would be on your own. From here, let's go ahead and move to our next example. We have what looks like a horizontal flat line in the bottom of the set, okay? So once again, we have our 2 points. Let's count how much we go up. In this case, we don't go up at all, it stays flat. So we rise 0, but we run 1, 2, 3 in a positive direction, giving us the slope, which we call an m value, rise over run, which will be 0 over 3, which if you reduce that down is 0. Notice we have a slope of 0. Please familiarize yourself with what this looks like, as the third question on your assessment is, draw an example of a slope of 0. One more. Notice we have a vertical line. I forgot to put the 2 dots on it, so I will go ahead and do that now. Once again, let's go ahead and count our rise in this particular case. We rise 1, 2, 3, and we run, well, we don't go anywhere. We just stay up and down. So we rise 3, we run 0, giving us a slope of 3 over 0. However, you can't do that. That kills puppies. You cannot divide by 0. I hope you remember that from like the first day of school. So therefore, this is what we would call an undefined slope. I'll give you a hint what the fourth question in your assessment is. What is an undefined slope? Draw an example. Ask each other questions if you have them. As always, I'm happy to help you tomorrow.